Hello guys, welcome to the channel Analyst Cadre. In the previous video, I have explained about print statement, variable type and assignment, and also few operators such as arithmetic operator, assignment operator, membership operator, and identity operator. In today's video, I'll be covering uh, membership operator, comparison operators, logical operators, and bitwise operators. Okay, so let me go to comparison operators first. So we use comparison operators to compare between two values or two operands. Okay, we have operators such as equal to, not equal to, greater than, less than, greater than or equal to, and less than or equal to. So let us perform these operations in code. Okay, so let me go to Jupyter notebook. Yep. So let me show you an example. Let a is equals to 15 and b is equals to 14. So print a greater than b. I'll try to explain all the operators at the same time. Let me type it first. So yeah, I have typed everything. Now in comparison operators and other operators like bitwise and logical operators, we'll be getting the output in Boolean format such as true or false, like we have seen here in yesterday video, where in membership operators and also identity operators, the output will be in the format of Boolean. So that is true and false. Okay, so since we have a is equals to 15 and b is equals to 14, we know that a is greater than b, so the output will be true. A is less than b, the output will be false. A is not equals to b, so yeah, both are not equal, so the answer will be true. A is greater than or equal to b. Since a is greater than b, we will be getting true. A is less than or equal to b is false because a is greater than b. Okay, so the output will be false. And a is equals to b because if we use single equal to, it's like we are assigning a value to the variable. But when we use double equals to, it's like comparing two values whether they are same or not. Okay, so the output will be true, false, true, true, false, false. Okay, yep, you can see true, false, true, true, false, false. Okay, this is about comparison operators. Now let us go through logical operators. Okay, so yeah, yep, we have in logical operators we have and, or, not. Okay, so similar to comparison operators, we'll be getting the output in true and false. Okay, so in AND operation, it returns true if both the statements are true. In OR operators, returns true if one of the statement is true. That means if you have multiple statements and in that statements at least one is true, then the output, final output, will also be true. But whereas in AND operator, both the statements should be true only. Okay, it is mandatory. If one of them is false, the answer will be false. Whereas in NOT, it reverses the result, returns false if the result is true. Okay, and vice versa for the true. Okay, if the answer is true, then it returns false. When the answer is false, it returns true. Okay, let me show you in the code. Yep. Yeah, we have and, or, and not operations. Okay, so yeah, a is equals to 15, b is equals to 14. Okay, now let me give an additional variable, that is x is equals to 1, or let me keep it 13. Okay, so yeah, print x less than a, and is a keyword because and is a operator. So and, or, not, these all are keywords. Okay, and x less than b, so both the operations are true because both the statements are true because x is 13 but it is less than 15. X is 13 and it is also less than 14, so the output will be true because in AND statement both the output should be true only to get the true value. Okay, yeah, now let me copy this. Yeah, if in case I have typed x is greater than b, which is clearly false because x is 13 and b is 14, but we know b is greater than x. So for AND operation, both the statements should be true, but here one of the statement is false, so the final output will also be false. Okay, yeah. Now we'll go to the OR operation, where at least one where at least one operation should be true to get true. Okay, x is greater than a, and we have to type OR because we are doing OR operation, so we need to type OR keyword. X is greater than less than b, the output will be true because it is not completely different from AND operation. If both the operations, I mean, if the both the statements are true, then it will return true. If one of the statement is also true, then it will return true. Okay. Print x is greater than a, which is true, or x is x is less than a, which is true, and also x is greater than b. This is false, but we'll be getting true because the or statement demands that at least one should be true to get the true. Okay. So we'll be getting for our statement this will be true and this also will be true. Yep. See, coming to not operation, unlike and or, we'll use not operation mostly for single value. Okay. So yeah, let me type it. A is equals to 15, B is equals to 14. So print, no problem. You can even use this for multiple variables too. Like I'll be showing you. A A is greater than B is true. Okay. So yeah. So print A is greater than B. I'll be getting true. Okay. Now if I use sorry. Now if I use not statement, I mean not operation, I'll be getting opposite of the final value. Okay. A greater than B. So we already know that. So yeah, we already know that A is greater than B, but we are using not operation, so it will return false because since there is description in the slide that reverse the result. Okay, so it returns false if the result is true. Okay, now let me show you another thing for the not statement, I mean not operation, that is yeah, print not of A less than B. Okay, we know that A is not less than B because A is 15, B is 14, but it will return true because the not operation will inverse the result. Okay, it will reverse the result, so I'll be getting true. Yeah, so this is about logical operations. Okay, now we'll go to bitwise operation. Bitwise operations are like they mostly work with bits are nothing but binary digits, that is zeros and ones. Okay, so zeros and ones are uh, computer understanding language. Okay, so the computer can easily understand zeros and ones because yeah, it is also known as machine language. Okay, so we use bitwise operators for fast operations. Okay, so we have similarly and or XOR not, and zero fill left shift and sign right shift. Okay, so yeah, here in previous logical operators we used small and or like in string format, whereas in bitwise operators we'll be using these symbols. Okay, this is and symbol, this is or, this is XOR, this is not, and this is left shift and this is right shift. Okay, so firstly to perform these operators we need to know what are binary digits. So yeah, this is, let us consider this is x-axis and this is y-axis. So these horizontals are binary values, whereas these are normal numerical values. Okay, so the binary value for 0 will be all zeros because this, suppose let us consider this as some positions. Okay, 1 2 4 8 16 32 on so on. So these are the binary values, like this we'll consider binary values. Okay, so for the numerical value 1, the binary value will be 0 0 0 0 1, like we are keeping 1 at the position 1. So since we know binary values only use zeros and ones, we will be keeping ones wherever we are adding two values or wherever we are getting the exact position. Okay, so for 3 there is no 3 position in the x-axis, so we need to add 2 and 1, so we'll be keeping two ones at place of 2 and 1. Okay, so yeah, 0 0 0 1 1. So similarly for 4, we have direct value 4, so we'll be keeping 1 at fourth place and remaining values will be 0. So the binary value of 4 will be 0 0 1 0 0, and for 5 we need to be adding 4 and 1, so 0 0 1 0 1. So this is like this, we'll be adding for multiple. So let me directly go to 8. Okay, so we already have the value 8 in the binary axis. So yeah, we'll be getting 0 1 0 0 0. For 9 we need to add 8 and 1, so we'll be getting 9, so that is 0 1 0 0 1. Okay, so since we use only binary and since we use only binary values, that is 0 and 1. So we need to keep 1 at the exact position or the adding position. So whereas all the remaining positions will be written as 0. Okay. So yeah, this is about binary table. Now you can easily understand the bitwise operations. So let me show you. Yep, we'll be using and. Okay. So each sets each bit to 1 if both bits are 1. Okay. So yeah, let me show you an example. We have, yeah, for suppose a is equals to 1, b is equals to uh, yep, 2. Okay, now let me convert this both values to binary values. Okay, so to convert binary values we also have a keyword in Python known as bin. Okay, so print bin. Okay, bin means binary, bin of a, print, sorry, we need to close the open parenthesis. So here we are opening a parenthesis, so we need to also close it here, and this parenthesis will also be closed. Okay, yep. Now we'll be printing print bin of b. So let me print this 0b1 0b1 0. Okay, so this might be somewhat confusing for you. Let me directly show you. Let me directly show you in the chart. So yeah, we came to the slide. Yep. So the one is 00001, and for the what value did we take? Yeah, and we took 2, so the value will be 00010. Okay, so according to the bitwise operations for AND operators, sets each bit to 1 if both bits are 1. Okay, uh, so if I explain this in code, you might not understand it properly. So let me gather some information online, and I'll just explain you theoretically. Uh, I'll make it very simple for you. So please give me a sec. So I'll be using ChatGPT, not for copying, but I'll just explain to you directly from the ChatGPT. Okay. Now I've already searched it in ChatGPT. I'll just explain you directly. So yeah, let me go to ChatGPT. Yeah. So we have this bitwise and bitwise or bitwise XOR, bitwise not, and left shift and right shift, right? So here you can see the rule is, since we know that if both bits are 1, the final will be 1. So the rule is 1 plus 1 is equals to 1, otherwise 0. So here the binary value for 5 is 0 1 0 1. Okay, so this is 1, this is 2, this is 4, this is 8. Okay, consider the markings. Okay, so 1, so adding 4 and 1 will give us 5. So similarly adding 2 and 1 will give us 3. Okay, so here uh, when we are considering 5 and 3, the binary values are 0 1 0 1 and 0 0 0 1 1. Okay, so here we have 1 1, so the output will be 1 here, because the rule is 1 and 1 is equals to 1. So similarly here 0 1 is 0, because both the values should be 1 to get 1. If 1 is different, then the output will be 0. So the entire thing is will be 0 and only 1 1 will be 1. Okay, so this is about AND operation, and similar to the logical operator, or at least if any bit is 1, result is 1. So at least if any bit is true, the entire output will be true in logical operator. So same like that, if any bit is 1, the output is 1. Okay, so here we have 1 1 will get 1, 0 1 will, since we have one a single one, we will get 1. Here also 1 0, we have a single one, so we'll be getting 1, and last we have both zeros, so we'll be getting 0. So this is about bitwise OR. Now coming to bitwise XOR, if bits are different, 1, if same 0. Okay, so for XOR it is different from OR statement. Okay, yeah, uh, you can see here, if bits are 1 it's 1, sorry, if bits are different it is 1, if same it is 0. Okay, so we have for 50101 and for 30011. So if 1 and 1 are same, so the output will be 0, because the rule is if both the values are same, then it should return 0. Okay, now here the both the values are different, so we'll be getting 1. Similarly, the both the values in here this line also are 0 different, so we'll be getting 1. And for the last we have the same value, so we'll be getting 0. So this is about bitwise XOR. Okay, now we'll go to bitwise not. Okay, so yeah, in bitwise not, it flips all the bits. Okay, so the flipping means reversing all the values, binary values. So if 0 will become 1 and 1 will become 0. So the binary values for 5 is 0 0 0 0 0 1 0 1. So the not bitwise not will return all ones for zeros, like 1 1 1 1 1 0 1 0. Okay, it will reverse the existing binary value. Okay, uh, yep. Now we'll go to left shift and right shift. Okay, each shift multiplies by 2. That means these examples are not quite clear. Let me show you a different example for easy understanding. For the left shift, it moves bits left. Okay, so the number becomes bigger. Okay, think of it like if x left shift 1 is like x into 2. So that means if 5 left shift 1, it means 5 into 2. Okay, so yeah, and for right shift it moves bits to right, the number becomes smaller. So it's like division. Okay, dividing. X right shift 1 will become x divided by 2. So 10 right shift 1 will become 10 divided by 2. So for one line memory trick, left shift means doubling and right shift means offing, like dividing the values. Okay, now we have some examples like yeah, these values like 4 left shift, these values denote how many times we have to multiply. I mean, how many times do we need to double the given value. Okay, so yeah, here we need to multiply only one time. So 2 into 2 4, same 3 into 2 6, 5 into 2 10. Similarly 4 into 2 8, 8 into 2 16. Okay, like this we'll be getting left shift values, and for right shift we'll be dividing. So 8 divided by 2 will be 4, 10 divided by 2 will be 5, 16 divided by 2 will be like what, 16 divided by 2 will be getting 8, 8 divided by 2 will be getting 4. Okay, then again 20 divided by 2 will be getting 10. So these are basic examples for left shift and right shift. Okay, so yeah, this is about bitwise operation. So I hope you understood, and in case of any doubts or any clarifications, please to comment in the comment box. And also, if in case you didn't understand anything, please do let me know, and please let me know how can I improve my explanation skills. And thank you for watching. Please like the video and also subscribe to the channel. Thank you.